So Christian is going to talk about his project Spacecraft.
Yes. All right. So yeah, today I'm gonna talk about what I've
Woohoo!
kind of. Thank you. Today I'm gonna talk about what I've kind of like changed with my movement in the spaceship. I'm just gonna quickly put this here because if you want to know kind of like what formula I'm using here, it's the typical drag equation. So it's basically based on the magical variable times the density of the fluid that's passing through, times the velocity squared divided by 2 times the area. So this is just reference. So I started off this by using the Unity version. So this is basically just like linear drag, and I had this with like a max speed. So before, when I tweaked my game, I had like a max speed of the spacecraft, and then I had this drag to kind of like I changed how fast the speed is increasing and decreasing. But this led to some like unfortunate effects. Like if I had a lot of drag, the ship would like slowly fall in the air from gravity. So I didn't like that. So I went back to my physics book and looked at, okay, I can start out using these physics formulas and see where it goes. So I started off like adding the like general things from a game, like okay, where am I? Okay, we're on Earth. Let's say that. So you add the density of air, we add what kind of gravity we have, and then I had to specify the ship because in the equation you see also we have area. So I have the dimension of the ship like 20 times 20 times 5 meters, and then I need some kind of mass. I'm like, okay, let's look at real things, tanks. How thick are they? Oh, about like the maximum is like two diameters in thickness. Right. So let's take some material. I took steel, and then we ended up with a mass of 1.8 million kilograms. I'm like, okay, fair enough. Let's go with this. Let's see where this leads. So I start off like, okay, let's start with gravity. We have gravity, and then we have the velocity downwards. Then we go with this drag thing. So basically, that's air molecules in air air atoms in resistance towards the direction of the velocity. So just adding this formula into the game with 4 different magical numbers. Yeah, okay, and let's have a video here. Okay. Not sure you can see it, but yeah, the lowest with like no drag is top left, and then with the highest number is the bottom right. So for reference, how this would be in like a real world, this seeding number would be like from like 0 to 1. So basically, this big piece of metal wouldn't have any they wouldn't have any effect on it in real life. But I went with like some value in between. What I ended up with having this it's based on the area and the direction. So if we have it from the front and from the bottom, it's gonna be different. So we see if it's front face down, it's gonna move faster to the ground just based on gravity. So you have these two forces, but actually most objects are not this uniformly spread with mass based on the area. So if you think you have like 2 balls with a hole between them, and one is made of metal and one is air, the center of mass will be closer to one side than the other, but the center of pressure will be in the middle. So that becomes something like this. And if we add this to the game, it will create a torque on the ship, and it will gradually move towards the direction it's going. And if we don't have any kind of drag on the angular momentum, it should just be a pendulum trying to move towards the direction it's going. But since there's nothing else, it's just gonna overshoot and try to go back again. So we needed to fix this. So I added something like torque drag, and this is where I'm going like way off my knowledge in this subject because it's fluid dynamics and I don't know how this works, and there's not really a lot of formulas for it. But I basically used the same formulas I had in start by just swapping out the velocity with the angular velocity, and it seems to work okay. Here's without any dragging the angular, and when you add it, it's just going to be, oh, it's fine. So now for some other movement in the gravity. Here I made a choice where I have all the forces from the center of mass instead of having a lot of like thrusters on all the different sides and then try to mimic how it should work. So I just added some forces there, and basically so I can move up and down and to the sideways. Then there was one thing, I'm not sure if it's easy to see here, but in the middle here, I'm moving with the velocity forward, and then I'm turning the ship with the bottom part towards the direction I'm going. And here's something I want to mimic a bit more what airplanes are doing. And this is by adding another force, which is lift force. So this is for airplanes. If they're going straight forward, they're mostly going a bit upward because they're wings. But here I want to have like no lift force from the front, but if you're angled a bit, I want to have some lift force because the air is hitting the area, so it's always perpendicular to the velocity direction. So I looked online how this works, and basically just it's kind of like for this magical number is based off the angle between how it's in the direction it's going, basically. So I just took this and approximated as like kind of like a sinus curve, added it in the game, and super small image, but you can see almost here that it's kind of like moving over the line slowly. So yeah, it kind of works. It's a small effect, but you kind of get it when it's going like downwards. You have like falling from gravity and you're just like moving the tip up, you can have more velocity forward. So to the last part, for the main engines, these, apart from the other linear forces, have them actually as objects on the ship, so the force is acted from them. So the more engines you add, the more velocity forward you will have. So if you misplace one of the engines, so you only have one engine on one side, it will create a torque on the ship. So if someone kills one of your engines, you're gonna have a hard time controlling the ship. So in conclusion, I have all these forces on the ship, and sort of the current state is something like this. So yeah, I have all the calculations in place now, just to play around with the variables to get something I'm happy with. So yeah, so this was what I was working with, and also I added some particle effects to the thrusters. So I have you can change it based on how much power I have into it, and also have like an overdrive for it.
Nice.
So that was it for me this week. Do you have any questions?
Yes, when can we play this?
In some time.
Can you stall out if you're climbing up?
If you can stall, not really, I think, because it's maybe. I don't think so, because all the power is coming from behind, so we're not really so much dependent on the lift force. So there, if you have power in the back engines, you're gonna move forwards, basically.
Are you also planning to do some atmospheric simulations? So, like, the higher you get, the rules will start changing?
Yes, I thought so. So this is why I've added the density as a factor in.
We have a question from the chat. I don't know if this is a real question, because I don't speak nerd. Will there be Borgs? I don't know what that is.
Don't know. Don't think so.
What is it?
I don't
It's
know.
a Star Trek
Yeah,
race.
Don't think so.
Shame.
Will this game be within the planet's atmosphere or also in outer space? Can you like fly from the atmosphere to space and continue like battling there?
So the question was if the game will only be in the atmosphere of a planet or if it will be in space as well. Correct. And I'm planning out to build it first around atmospheres of planets and then go for space and see if that fits as well. That's all. Thank you very much.